Good morning, everybody. It's great to see all of your faces. Great to see your names. Quick reminder to folks, we are going to officially kick off in just a minute or so. But if you haven't had a chance yet to rename yourself with your first name
and the person's email,
your location, that would be great. And then also, if this is a great time to make sure that you're muted. So if you can check the mute function as well. But if everybody wants to unmute themselves and just say, good morning. Thanks so much.
Morning.
Good morning.
Good morning.
Good morning.
Good morning.
Good morning.
Good morning.
Everyone.
Morning.
Good morning.
Great.
Good morning.
Good morning.
Good morning.
Excellent. It's wonderful seeing everybody. It's great hearing your voices in this virtual space that we're in. Welcome to the third learning session. And just quickly, I'm going to check in with Brent. Are we good to go and to formally kick off?
I believe so. Yes, we are live.
Okay, excellent. So with that, my name is Gretchen Muller, and I just want to welcome each and every one of you to the learning session number 3 for the Washington Climate Assembly. We will be meeting today from 10 a.m. to 1 p.m. We have a list of great speakers for you all. We also have more time for question and answer. We have our around the campfire activity and some additional times for you all to share your reflections and to connect with one another. And if folks can just first of all, if you can take a moment, if you haven't had a chance yet, to rename yourself and to your first name and your location. So you would go ahead and click on participants, hover over your name, move to more, and then rename with your first name and location. And we'll help you do that as well if you're having any issues with that, but just want to remind folks to take a quick moment to do that. If you're a presenter, your first name and last name, comma, presenter. And if you are an observer, your first name, last name, comma, observer. And with that, a reminder too, if anything goes wrong, I do want to remind folks that from a tech side, we can help you with tech. I don't know if we can help you with other things, but we can help you with tech. To please reach out to Brent Edgar at brent@cascadiaconsulting.com. And Emily nicely put that in the chat too, phone number 206-449-1172. So if anything does come up throughout the course of our day today, tech-wise, please don't hesitate to reach out to him. He's here to help and to support throughout the course of the day. And if folks can just take one moment in the chat, if you're willing to share with us one word that either describes how you're feeling about today's meeting, describes where you're at in this moment in the chat. We've got hopeful, pumped, stoked, intrigued, ready, eager, excited, ready to go, curious, hopeful, science, ready, excited and alert, energized, interested. Excellent. Thank you all so much. Hopeful, ready, great. A lot of readies, excellent. Folks, sounds like people have their coffee, they're ready to go. And a reminder too, I recognize, this is a Saturday morning, it's a 3-hour meeting, even though we do have a break and we have more reflection time and more time for Q&A. If at any time you need to get up, you need to stretch your legs, you need to grab a snack or something to drink, take a tiny mini break, please take care of yourselves throughout the course of the morning as well. And starting with a land acknowledgement as well, that we wish to acknowledge that the people of Washington State live and work on traditional lands of the indigenous people who've been here since time immemorial. There are 29 federally recognized tribes and 7 non-federally recognized tribes within the boundaries of Washington State. Tribes and tribal people bring thousands of years of traditional knowledge to our present moment. Tribes bring an important and vital voice to our current conversation, and we honor tribal relations. And with that, I want to formally and informally welcome all of you and turn it over to Mike to walk through today's agenda.
Great, thanks, Gretchen. Again, welcome everyone to today's agenda. So first of all, again, just reminding people about your feedback. So we're going to just show you where you can provide feedback. Again, this is your assembly, so we want to be responsive to how we can improve and how we can tailor this assembly process for you. We'll then have a set of presentations, and then we'll have a break in between where we'll also have time in breakout rooms to just process and debrief some of the presentations in the same groups that we did at the end of the Tuesday learning session. Then we'll have a second part of presentations, and then we'll do the breakout rooms around the campfire again, and then outline next steps and conclude. So some of the things what we heard from learning session 2, we learned a lot about the basics of climate change, the causes of climate change, and the role of carbon emissions in the greenhouse effect from Dr. Amy Snover, Dr. Chris Ebi, and Dr. Deb Morrison. We also learned about climate impacts across Washington State, the United States, and across the world from Dr. Snover, Dr. Claire Richards, and Dr. Ebi, understanding that climate impacts are not felt equally by everyone. And then finally, we learned about the composition of statewide carbon emissions from Hester and how transportation is a large part of those statewide carbon emissions. We learned from Hester and Dr. Morrison about the potential climate change and climate mitigation solutions within the transportation and the education sectors as well. So again, framing this in the broader, I guess the syllabus that we're going through with each other is, we talked about the basics of climate change. We talked about how climate impacts affect different communities differently and beginning to learn some of the solutions. And today we're going to be learning about what are some of the environmental considerations, what are some of the impacts and the potential that the environment can play in the role for climate mitigation in Washington State. And so going over some of the meeting objectives. So what are some of the learning objectives that we have in mind for you today? So today we have multiple experts who will be presenting on some of the environmental considerations of climate impacts and climate mitigation solutions. Well, you will hear from multiple experts about climate impacts on a variety of Washington's ecosystems, including forests, marine ecosystems, and wildlife, and other types of habitats. We will also hear from experts and interested parties on the role that these natural ecosystems can play and the potential that they have for climate mitigation. Finally, we will continue to build off of this knowledge and this learning with other experts and interested parties who will begin to draw connections between the environment and other sectors that deal with sustainability. So I'll turn it back over to Gretchen to quickly walk through the feedback again.
Excellent. Thank you so much, Mike. And yeah, just wanting to remind you all of 4 potential ways to provide feedback. One is in these meetings in real time, submitting questions to presenters in the chat. The other is if there's a topic you want to dive more deeply into or want more information about, to please let us know. On the website, there is a link to a place where you can also upload and share independent research. So if you have time and interest and wanting to dive more deeply into any particular area related to this assembly, and you found a document that you really think is great and want to share it with your fellow assembly members, that's where you can do it. And then also the general feedback. And so at the end of each session, we'll be providing a link in the chat and for a feedback form. And we read these diligently, and we go through them and we think about ways to incorporate the feedback that we're hearing from you all and try to work in the suggestions that we've heard. And this is Washington State's first ever People's Assembly, and we're committing to making improvements every step of the way. So please let us know. And we've updated the feedback form, so it's new and improved from Tuesday. So please check it out after this meeting and share your thoughts. And for instance, how is this information being used? So we got feedback about having more opportunities for smaller group discussions. So we've incorporated that in 2 ways today. One is moving you all into breakout rooms during the break. So you have the option for casual conversation during break if you'd like to use your break that way. for either part or the whole time. We've also carved out additional time at the end, and we're calling it around the campfire, and as a breakout session. So doing what we did on Tuesday, but extending the time a bit more. We've carved out additional time for Q&A sessions. And we've also created an online folder that we'll send you all a link to, which will include all past presentations. It will include resources that have been shared by presenters, as well as a glossary that we'll keep adding to. And these will be terms that we've been hearing from each of the presenters that may not be a word that we use in everyday conversations. And if there are words that come up that are unfamiliar to you as well, please let us know and we'll add those to the glossary as well. So really just can't iterate enough that your feedback is really important. We read it and we try to incorporate what we can within the parameters of this assembly. So thank you all so much. And with that, we will go ahead and move into our presentations. And we've got 2 parts similar to what we did last Saturday, part 1 and then part 2. And we are kicking off and are lucky to have Dr. Mead Crosby, who will be presenting on climate impacts on habitat and wildlife as an expert presenter. Dr. Crosby is a senior scientist with the University of Washington's Climate Impacts Group and the university's deputy director of the Northwest Climate Adaptation Science Center. Dr. Crosby has spent the past decade working collaboratively with federal, state, and local governments, tribes and First Nations, non-governmental organizations, and communities to address climate risks to species and ecosystems. The learning objective from her presentation is to learn about the impacts of climate change on habitat and wildlife. Thank you so much for being here, Dr. Mead Crosby.
Thanks for having me. Hi, everybody. Can you hear me okay?
Yes.
Great. Okay. I'm going to talk about how climate change is affecting Washington's wildlife and habitat. I know you guys have had a couple learning sessions already, so I'm not going to go into a lot of the basics around the changes that are happening that are driving what's happening to these species, but I'm going to start with some general trends in the kinds of things that we're seeing in wildlife here and around the world because of climate change, and then some specifics about the things that we're seeing in Washington's wildlife and habitats. So some of the things that we're seeing globally that's also playing out here include changes in the timing of biological events. And so what do I mean by that? Things like when leaves come out in the spring, when flowers come out in the spring, when insects emerge from their winter hibernation, when birds return from migration in the spring and lay eggs. So all of these biological events, they're all closely attuned to things like climate, and species are responding to warming by changing the timing of when they do these things, and they're doing them earlier. So spring has actually been getting earlier around 3 days per decade in the Northern Hemisphere, like where we are. Birds are coming back earlier, leaves are coming out earlier, flowers are coming out earlier. And these are good things because this means that species are adapting. This is one way that they adapt to climate change. The problem is that they're not all changing the timing at the same rate. So then we get into problems where you have things like flowers coming out before bumblebees emerge, for example, and now your pollinators are not aligned with the flowers that they pollinate. Or you have insects emerging because they're up in the north and they're coming out earlier in spring, but the migratory birds are still down in South America or Central America, and they're coming back too late and the insects are gone, and that's what they feed their babies. And so these mismatches in timing are a real problem and something that we're concerned about under climate change. Another thing that we're seeing is that species are changing their distribution. So the ranges of species, where you find a species on the landscape, these ranges are changing. And they're changing again in an adaptive way, and that this is another way that species respond to climate change. It's not just by changing the timing of when they do things, but also where they're found. So as it's been getting warmer, on average globally, species ranges have been shifting northward and upward. So they're moving their ranges to stay climatically comfortable as it warms. They're moving to cooler places. Again, this is a good thing, right? They're adapting. This is how they've always adapted to change. The problem is that climate is changing extremely rapidly right now, more rapidly than in millions of years. And so it's difficult for species to keep up, and especially species that don't have wings or species that can't move very quickly. And some species just don't have anywhere to go. So for example, here in Washington, we have these adorable critters, pika, that live way up in alpine habitats up at the tops of mountains. The only place to go is up. So they have a really hard time adjusting their ranges, because at the edges of their range, they'd have to go down mountains and back up and, like travel across the landscape. It's very difficult for them to do that. So we're seeing at the southern edges of their range, like in the Sierra Nevada and California, these guys are starting to disappear. And you'll see things like that that southern edge of ranges starting to move northward as they just can't keep up with the changes that are happening. So that's a problem. We expect to see dramatic changes in where species are found. Some ranges will shrink, some species will disappear, some will be winners and their ranges will grow. But on average, this is not a good thing for plants and animals, that they're having to keep up with really rapid changes. The other thing is, just like species are changing the timing of their events, not all at the same pace, they're not all moving at the same pace either. And they're not all moving in exactly the same places. On average, they're moving up and they're moving north. But they're all taking slightly different paths. Their ranges are all responding differently. And so what that means is that we can actually wind up with really different kinds of ecological communities. And when I say ecological community, I mean the plants and animals that you find in a given area. So you go into a forest in Washington State, say on the west side of the Cascades, you kind of know what you expect to see. I'll see some hemlock, some fir, there'll be some huckleberry. That's an ecological community. Maybe there's some deer. Those communities, even though they seem very permanent to us, they've changed a lot over historical time. This is, we've always had changes in our ecological communities, but with the pace of climate change happening now and how quickly species are moving, we expect to see pretty different communities emerge in the future. We might have very different looking forests. We might have very different alpine communities, like up here with, we have trees moving into alpine meadows. On average, there is much less uncertainty around what that might look like west of the Cascades. We'll probably still have evergreen forests, conifer forests. It might be a little bit different than what we've had in the past. There's more uncertainty around what's going to happen east of the Cascades, like in the Columbia Plateau. Questions about how much grassland versus shrub versus forest might be there. We could have some pretty dramatic changes, and we don't know exactly what those will look like yet. The other thing to consider is that while species are adjusting their ranges and they're all trying to keep up with climate change and stay in climatically suitable areas, this isn't a sort of slow, steady process. It actually can happen pretty quickly and pretty dramatically. And typically these changes will happen after a big disturbance. And by disturbance, I mean something like a big fire or a flood or some other event that can change the landscape very quickly. And so after a fire, you might have had a forest there, for example, and the trees there could handle some warming. They could handle some drier summers, but maybe their seedlings can't. Maybe their seeds won't germinate and give rise to these seedlings and the new generation of trees under these hotter and drier conditions. And so that forest might be replaced by grass or something else that's better adapted to that heat, or different kinds of trees that are better adapted to these new conditions. And so when we see these changes in ecological communities and what kind of plants and animals we find in a spot, it'll often happen quite quickly after events like big fires. And we've been seeing more fire, and I know Dr. Hollowski is going to talk more about this later. And we're seeing more fire because it's getting drier, it's getting hotter in the summer, it's hotter and drier for longer. And our forests are stressed by these conditions. And so we're having more insect and pathogen outbreaks, more diseases. And in the near term, these insects and pathogens give rise to more fire. And so our forests are stressed, they're burning more often. And again, I think maybe someone's going to talk more about this later, but these larger wildfires are expected to reduce the ability of our forests to store carbon. And so this is also a concern. And so the more we can do to restore our forests, and we've been suppressing fire for a long time in our forests, the more we can do to remove these extra fuels, to restore more natural fire regimes, the more resilient our forests will be and the more carbon they'll be able to store. So the warming temperatures that we're seeing, which you probably heard about in the last 2 sessions, are leading to habitat loss also for species that depend on snow, on cold environments, and in particular snow. So we've lost about 25% of our snowpack in the Cascades since mid-20th century. We've lost a lot of ice, and some species really need this snow and this ice. Species like wolverine. If you don't know about these guys, they are amazing creatures. They can travel huge distances. They are so hardy, and they are just sort of icons of our remote, rugged landscapes in Washington. But they need snow, and they don't just need any snow. They need a lot of snow, and they need it in the spring. And they dig into the snow, and that's where they have babies, and that's where they raise them. And so spring snowpack in particular is disappearing in the Cascades because it's getting warmer earlier, it's melting earlier, and these guys are losing their habitat. And by the end of the century, there's really dramatic reductions in our spring snowpack in Washington, and it doesn't look that great for wolverine and their ability to stay in our state past the end of the century. So everything we can do to mitigate and reduce that loss of spring snowpack and keep it colder longer for more snow will do good things for species like wolverine that depend on that. Our freshwater species, our fishes, are also going to be really affected by the changing conditions, and that's especially true of salmon. So salmon are affected by climate change at every stage in their pretty complex life cycle. So, for example, when they lay their eggs in freshwater streams and rivers, those are really sensitive to things like winter flooding, which we're going to see more of under climate change. So we're going to have less of our winter precipitation falling as snow, and more of it falling as rain, and more of that rain, and it's going to go right into our rivers and streams, and we're going to have more flooding, higher flows. Those can wash away salmon eggs out of our stream and also introduce a lot of sediment, a lot of grit and dirt into our streams, which is not good for salmon development. So both of those things affect salmon when they're very young. When they get out into the ocean, we have these warmer oceans that are acidifying, they're becoming more acidic. That's affecting the food that salmon eat out in the ocean. And so they're having a harder time getting the food they need to grow over those years they're in the ocean to return back to our streams. When they get back to our streams, they're getting warmer. The streams are getting warmer in the summer because our summers are warmer. And salmon are very sensitive to warm water. They can't survive beyond a certain threshold of warm water, and they will die, and they can't pass through these really hot waters. And we've had salmon die-offs during particularly warm spells and warm spells of warm water. So this is a problem. And again, the more warming we have, the more this will be a problem, the harder the impact on salmon in Washington. At the same time, because we have our snowpack diminishing and the amount of snow that we have in the spring, that's our summer water for our streams. And so we're seeing lower summer flow. So our rivers are becoming barriers to salmon returning to breed because they're getting warmer and because there's less water there to begin with. So they have, it can be much harder for them to move upstream to get to where they need to breed. We're also seeing sea level rise. Globally, I know you've already talked about sea level rise in your earlier sessions. You probably talked about the fact that in Washington state, different areas are seeing different relative amounts of sea level rise because our coastlines are kind of rising and falling in different areas at different rates because of sort of the mountain building going on where we live and tectonic plates. But on average, we're seeing sea level rise in Washington state, and that affects our coastal habitats. So coastal marshes, and all the different habitats we have, our estuarine habitats, where our freshwater meets the sea, all of those habitats are being affected by the salt water that's moving into these freshwater areas along the coast, and also sea level rise making these coastal habitats disappear underwater or having to shift inland. So just like other species are having to move, our coastal habitats are having to move. They're having to keep up as the water rises and move inland and reestablish. And then we're also, I mentioned ocean acidification a moment ago around salmon. That's not just affecting salmon's food out in the deep ocean, it's also affecting our coastal waters. Washington is kind of a canary in the coal mine around ocean acidification. We're seeing really high rates of acidification in Washington state. It's expected to, acidity in our oceans are expected to increase 100 to 150% by the end of the century. And Washington, we have a really, our shellfish are so important for our economy, for our indigenous communities and their culture and livelihoods. And so we're seeing this affecting oysters, crabs, all of the shellfish that are so important in Washington they can't develop their shells as effectively as our ocean gets more acidic. And so that's affecting their populations pretty dramatically. And so mitigation, reducing our emissions, is really important to reducing the impacts of climate change on our wildlife and habitats. So for example, by limiting warming to 1.5 degrees Celsius versus 2 degrees, just half a degree of warming, globally means that the number of vertebrates, the number of animals with backbones and plant species, they're expected to lose, the expectation that they will lose over half of their range. So that the area that they're found in, that the idea that that could shrink in half, that risk is cut in half if we just can limit our warming by half a degree. The number of insect species.
Sorry, quickly, 1 minute warning.
Great. The number of insect species expected to lose over half the range is cut by 2/3 if we can limit warming by that half a degree. The amount of land area expected to be affected by that ecosystem transformation by turning into a different kind of community, that risk is halved by limiting it to that half a degree. And we have natural solutions. If we can just restore those forests, we can plant more trees, if we can restore our habitats, learn to store more carbon in our soils, we can use natural solutions to climate change just by managing our lands better to account for 37%, up to 37% of our emission reductions by 2030 to meet our Paris goal of keeping warming under 2 degrees. And finally, it's not just our forests. We also, again, we have these coastal habitats. We have things like seagrass. We have blue carbon where we can store emissions. And so, for example, if the entire Snohomish estuary in Puget Sound was restored, we could store almost 9 million tons of carbon over the next 100 years, offsetting 900 million gallons of gas or 1.7 million cars for a year. So lots of natural solutions out there as well. Thank you.
Excellent. Thanks so much, Dr. Crosby. Appreciate your presentation. And we are just going to take a moment. You can stare off into the distance. I know we're doing a lot of looking at screens this morning. So if you need to stand up, if you need to stretch, just going to, I know this is a heavy topic and folks are processing it all differently. So take care of yourselves, take deep breaths, stand up if you need to. Great. So we are going to move into the next presentation. And this presentation is by Paul Williams, who will be presenting on marine life as an expert presenter. Hi, Paul. Thank you so much for joining us today.
Morning.
Good morning. Senior biologist at the Suquamish tribe and provides assistance in all things related to shellfish, including resource management, ocean acidification research, and more. He's currently developing the Suquamish Climate Change Resilience Plan and helping the Puget Sound Partnership develop their action agenda. And the learning objective here is to learn about impacts of climate change on marine systems. Thank you so much for joining us.
Thank you. So here we go. As I mentioned, I'm going to talk about impacts of carbon pollution on marine life. And next slide, please. First off, I just wanted to ask you all a question. Think about when this quote when was it spoken and by whom? A couple of seconds, we can just go to the next slide. So it was President Lyndon Johnson back in 1965. Generation has altered the composition of the atmosphere on a global scale. So we've known about this problem for a long time, and it just keeps getting worse. Next slide, please. I'm going to talk about the ocean conditions. Ocean warming, sea level rise, decreased oxygen, ocean acidification are the big ones. There's a few others, but we won't get into that. I'll also try to touch on some of the impacts of the tribes. And also, I'm going to ask you another question, is whether you think we're in a state of emergency. And then I'll mention a few solutions that I've been thinking about. Thank you. Next. So here's a map of the ocean. And of the heat content. It's been going up, and you can see the red spots. It's where it's quite a bit warmer. In a few areas it's cooler, but on the average you see a lot of pink areas. One thing to note about the ocean is it covers 70% of the surface of the earth. It feeds 3 billion people, and for most of those people, most of those 3 billion, the ocean provides their main source of protein. And the ocean provides half of the oxygen that we breathe. So you can think about it, every other breath you take comes from the ocean. Last little fact is that 80% of the population of the world's global population lives within 60 miles of the coast. And about 3/4 of the major cities, the big mega cities, are on the coast. So what happens when the ocean warms? Heat makes things bigger, it expands water, so we're getting sea level rise. So as that sea level rises, we have big issues with whoever's living next to the coast. So on a Pacific coast, there's several tribal communities that are going to have to move inland. And as Mead mentioned, we've got coastal flooding happens when you have high tides plus storms. You get these massive storm surge, and you can get flooding into communities, into coastal areas. And when the sea level, when the flood goes back down, it brings with it all kinds of pollutants and toxins that might have been on the ground. So then it's a kind of an impact to all the marine life offshore. Another thing that's happening with sea level rise is that as the seawater intrudes, it actually raises the level of the groundwater, and that can cause flooding in basements. It can, break infrastructure, underground pipes, roads can buckle, and it also comes in and intrudes into agricultural areas, and so you get this salt water, and that doesn't, plants don't like salt water to grow in, so that's a major potential impact there. Next slide, please. Now, what happens to fish when they are in warmer water? Fish like to stay where the water suits them, so they can swim. They migrate to areas where it's a little cooler. And so in temperate areas, you're seeing more tropical and subtropical fish moving into temperate areas and harvested. And in the tropics, though, we're just going to see fewer fish. And that's where a lot of the folks that depend on food, on fishing for food resources live. So that's this is a very large impact in food security. Next slide, please. And we also have now, we mentioned the impacts that can be very fast or very slow. The shift in where the fish are is kind of a gradual impact, but 2014 to 2016, we had the blob out in the Pacific, and temperatures got 3 degrees higher than normal, 3 degrees Celsius, which is a lot for a fish that's used to being in 10-degree water. What happened there is that we had fisheries collapse in many different areas. They were just disasters. Chinook, the Fraser River sockeye didn't show up for a few years, cod in Alaska. And then also we had, next slide, please. A tremendous algal bloom. This isn't a picture of that bloom, but it's a picture of an algal bloom. And that was in 2017. And algal bloom, it's a harmful algal bloom. It contained domoic acid. Domoic acid creates permanent memory loss. And so crab fisheries were shut down, and the coastal economy, crab fishing economy, lost $97 million that year. Also, clam fisheries were shut down. So that impacted everyone on the coast, all the fishing communities. We also have harmful algal blooms here in Puget Sound. The main one happens is paralotic shellfish poison, and Department of Health checks every week for that. And so we open and close shellfish fisheries, clam and oysters and gooey ducks based on those reports. And those seem to be increasing. And scientists are looking at the relationship between harmful algal blooms and the changes happening in the water, and they're beginning to identify those links. Next slide, please. Another impact of what's going on the ocean and in Puget Sound, Hood Canal especially, is low oxygen. Fish, and everything, all animals need oxygen. And when and warm water just holds less oxygen. And when you combine that with a big algal bloom, when the algae blooms, it dies, the plant, it's decomposed by bacteria, and those bacteria use oxygen so they can deplete the water of oxygen. And then you get this combination, and you can get massive die-offs, and they're called dead zones, and they can happen every year or sporadically. In Hood Canal, we get them just every once in a while. Next slide, please. Now we're going to get into the ocean acidification impacts. So here's a slide from over in Hawaii, and you see the green. The red is the atmospheric CO2. The green is the CO2 in the water, and the blue is the pH of the water. So the thing about pH is that as you go down, as the acidity increases, the number decreases. So the bigger numbers are basic, lower numbers below 7 is acidic. So technically, the water is not getting more acidic, it's getting less basic. And so as acidity regulates all kinds of things in the body. If you want a little experiment, hold your breath. As you start to panic, that's not oxygen your body is sensing. It's actually carbon dioxide in your blood. That's what triggers the panic that happens, when you hold your breath. So how does ocean acidification, next slide, please. Here's the chemical process, and I'm including this, so for those who are interested in actually how it works. You've got atmospheric carbon dioxide going into the ocean. It gets dissolved, combines with water, forms carbonic acid, and then that carbonic acid breaks down into hydrogen ion. And here's where the problem occurs, is the hydrogen ion grabs a carbonate ion, forms bicarbonate. Now what a shell is, you go down and look right at the bottom, is calcium carbonate. It's a calcium ion plus a carbonate ion. So when the hydrogen grabs that carbonate, it forms bicarbonate, and it makes it so it's not available to shellfish to form their shells. So it's more energy for shellfish to form their shells, and that is causing problems for all sorts of animals. Pteropods, next slide, please. So here's this kind of a list of the various little creatures that are being impacted. Pteropods are also known as sea butterflies, and they float around. Very important prey item for all sorts of marine animals, and they're very susceptible, and their shells are dissolving slowly, but they're being impacted. Recent research, and then barnacles and bivalves. What happens with clams is that they can't form their shells fast enough, and if it's acidic water, that they die. Recent research is identified the problem with larval crab. There's little tiny holes popping up in their shells, and they're also smaller ones in acidified waters. And then as you get down to the bottom, you see jellyfish. Probably it's not going to be an issue for jellyfish. So if we lose shellfish, clams and crabs, there'll still be jellyfish, and maybe that'll be, we'll get used to eating those. Next slide, please. So the food web impacts are really, really important. Everything's connected, and these little coccolithophores are eaten by copepods, and they're eaten by salmon. So are the pteropods eaten by salmon. And then, of course, the orcas, salmon get eaten by orcas, and we like them also. Next slide, please. So those are the major impacts, ocean impacts, just kind of briefly. And then how does it impact tribes? Is that tribes have, treaty rights. I think somebody might have gone through these, but, back in 1855, the tribes entered a treaty with the federal government, and they gave up access to all the ceded areas here, and they just retained reservation lands and access to half of the natural resources. And for many years, the state ignored those treaties. Tribes had to sue. 1974, they won the Bolt decision, got access back to the salmon. In 94, got access to the shellfish. And I was hired by the tribe in 1991. My job was to help develop access to all the shellfish species. So it's next slide, please. It's been tremendously impactful for tribes to regain access. There's a source of income for dozens of families. We've got about 24 geoduck harvesters and about 20 crab fishermen, and then over 100 people go out and dig clams. We have worked to recertify areas for growing areas. We have a very expansive, large aquaculture operation where we replant clams, and we lease tidelands from private property owners and plant and harvest there also, and it gives them a little income.
I'm just going to jump in here. We've got 1 minute left.
1 minute left, and go straight to the solutions. I have a couple of solutions. Next slide. So, sadly, there's not much we in Washington, there's not a lot of technical fixes, that we can do to cool the ocean back down or to stop ocean acidification. Those are global impacts that have global changes that have very local impacts. So we can do a couple of things. And well, let me, I kind of got ahead of myself. You got, hatcheries can buffer the seawater so they can keep clams and oysters, get them through the very vulnerable larval stages, but you can't buffer the entire ocean. So, that's not going to work for all the other species. You can grow seaweed. That works to a very limited extent. And we can protect eelgrass areas and kelp areas. That also helps. But really what we need to do is transition to clean energy. And that's happening right now. The price of electricity solar panels has really dropped. And there's tremendous potential. Then that's also where the jobs are. And the Department of Labor Statistics estimates that 51% of the will be increase of 51% in employment in that sector in solar power installation. So if you're interested in really addressing the bigger pictures of reducing carbon emissions and the shift to a just transition, looking at our school system and ensuring that the school system is providing education to underserved communities will both reduce the amount of emissions and also provide access to those good paying jobs. Too often, emerging opportunities are taken by people in positions, that have the money and resources to do that. And this is an opportunity to shift that. The public school system is $13 billion.
We do need to move on. So final thoughts from you?
Yes. The public school system, we spend $13 billion a year. It's nearly half the state budget. If we work there, we can change human behaviors and prepare youth for the green jobs of tomorrow. Thank you.
Excellent. Thank you so much. Really appreciate your presentation and for being here today. And we are going to take about 30 seconds before we introduce our next speaker. Okay, our next speaker is Dr. Jessica Hollowski, and she'll be presenting on forest health and fires, as an expert presenter. Dr. Hollowski is the director of USDA's Northwest Climate Hub and the Forest Service Western Wildland Environmental Threat Assessment Center. Jessica pioneered one of the first climate change vulnerability assessment and adaptation projects with Olympic National Forest and Park, and has since co-led 8 other sub-regional to regional scale climate change vulnerability assessment and adaptation projects across the Western United States. Learning objective here is to learn about wildfires and their impacts on community and potential for healthy forests to be a component of climate mitigation. And with that, I will turn it over to you, Jessica Hollowski. Thank you so much for joining us today.
Great, thanks, Gretchen. Good morning, everybody. So I'm going to hop right to it and talk about some recent statistics in our region. So many of you remember in 2014, we had Washington State's largest wildfire, over 250 acre fire in Eastern Washington called the Carlton Complex Fire. In 2015, also known as the year without snow, we had about 1.7 million acres burned in the Pacific Northwest, in Oregon and Washington, and over 9 million burned in the Western US. And this is a satellite image in August of 2015. So you can see that the large number of wildfires we had that year in our region. And we had a couple fires in 2015 that occurred on the west side conifer forests, including on the Olympic Peninsula, our temperate rainforest, where we measure rainfall in meters instead of centimeters. And these fire footprints are starting to collide. So this is an image around Mount Adams in southwestern Washington. And these are the footprints of 3 different fires we've had since 2008. And there's a location there. The areas in orange have burned twice since 2008. And that area in red has actually burned 3 times since 2008. So we're getting these areas of reburn over a relatively short period of time. And that's what that area that's burned 3 times looks like now. And then, of course, we had the Labor Day fires of 2020. So these are images mostly of Oregon, Western Oregon. Western Washington kind of dodged a bullet this year, although we did have some pretty severe fires on the east side. So in these events, we know that the east winds were a key driver of fire spread. We've actually seen events like this in the past, so we can't necessarily call them climate change fires. But what we can say is we know they're consistent with the kind of fires we might expect to occur more frequently in the future. So we're looking at, how are fires going to change in the future, and how do we know? So there are a couple of different sources of information we use to look at and project how fires might change in the future. And I'm going to go through a couple of examples of each of these. So the first is our paleoecological record. So that's a long word. But what do? We have in the bottom of lakes, in the sediment or the muck at the bottom of the lake, there are different layers of material that have been laid down over thousands of years. So what scientists do is they take cores of the sediments in the lake, and they look at pollen from different plant species, and they also look at charcoal. And with that information and where the pollen and charcoal occurs in that sediment, they're able to reconstruct climate and vegetation composition of the past. So we can look over time, and here on this left-hand side, the bottom is 17,000 years ago, going up to 0 to the present. And we can look at fire there on the left, and then we look at different species. Now, you don't have to get caught up in the details, except what we can see from this is both the climate has driven changes in our forest and vegetation communities over time, and it's also changed fire over time. And they've changed together. Shifts in fire have led to shifts in vegetation over time. So we expect these to occur with climate change in the future. We can also look at tree ring records. So we can, I know you've all probably seen what a tree ring record looks like, but what you might not know is that fires actually leave a mark in these tree ring records. So by looking at these records under microscopes, we can say not only how trees have grown in the past and how quickly and how that has changed with climate, but we can also see when fires occurred in these records. And so we can say that in the past, in general in our region, when we've had warm and dry summers in the Pacific Northwest, we've had more fires. So in the future, we're expecting increasing air temperatures. We're expecting less summer rain than we already get. We're expecting the snow to melt off earlier. And this is all going to lead to drier fuels and drier forests. And so we have these longer fire seasons and more extreme fire hazard. We're expecting more fire to occur. And it really just takes a couple weeks of high temperature or low rainfall to really dry out our fuels in the summer. So exactly what are we expecting here in terms of the future? So these are our projections for the middle of the century. And what they show is, you have to look at the exact numbers, but overall in the Northwest, if our temperature, average annual temperatures increase by about 2 degrees Fahrenheit, we're looking at about 2 or 3 more times annual area burned. And the models might be slightly different in terms of what they project for the future, but there is absolute consistency among models that we are likely to see more fire in the Pacific Northwest with climate change in the future. And we're also expecting more large wildfires. So we have kind of our baseline normal here on the left for a historical period, and then future for up to 2020, which is about now, and then mid-century in the middle and end of century on the right. And basically what you can see is that the redder it gets, the more we're expecting increased suitability for large fires. So in Washington, this is particularly the case east of the Cascades. Not quite as much for the west side, but as we saw this year, we can have large west side fire events if the conditions are right. We also know that climate change affects insects. So this little guy is the mountain pine beetle. This is a native species. We've had mountain pine beetle infestations and attacks as a part of our forest ecosystems for centuries, but the warming we've seen with climate change has actually favored mountain pine beetle. It's able to actually increase its reproductive rate in some places where it used to take 2 years for a complete reproductive cycle. It's happening in 1. And the warmer temperatures have allowed it to expand its range to areas where it hasn't occurred historically. And these are the, in red here, the mountain pine beetle attacks across Western North America since 1990. And you can see British Columbia has been hit especially hard, but these mountain pine beetle outbreaks have affected over 50 million acres. And we're expecting these different disturbances to interact in the future. So we have climate, fire, insects, and disease, changes in vegetation with changing climate, and invasives. And these interactions do have the potential to cause some surprises in the future. So what does this mean for our Washington forests and beyond? Well, as I said, the high severity reburns are especially of concern, where we're getting several fires in the same place over a relatively short period of time, and like a 20 to 30 year period. And that's because it's really hard for forests to recover when we have those high severity reburns. And so in those cases, when we have these reburns, we probably won't have trees in those places for quite a long time, because it may be difficult for trees to regenerate and to get seed into those areas. And we also have, effects of our past management. And with fire suppression, we put out most fires across our landscape. And this has meant that the forests have become denser over time, especially our forests that historically had a lot more fires. So these are our drier east side forests. And what that's done is it's created higher severity fires, where we have these large patches of almost complete tree mortality. And we're seeing in the past 50 years or so that we're getting these larger patches of high severity fire. And that those patches will be harder for seeds to get in there for our forests to regenerate in the future. We also know that tree seedling regeneration is very sensitive to climate. Now, our big 350-year-old Douglas fir trees, they can withstand quite a lot of climate variation. These little tree seedlings are much more sensitive, and so that's kind of a bottleneck. If we get a major fire event and then have extreme drought afterwards, it could take a long time for those forests to regenerate naturally. And again, we know that drought makes our tree species more susceptible to insect outbreaks and disease and mortality. And then we also could have some interactions with fire. So again, there's a potential for surprises with these interactions with our different forest disturbances. And then all of these changes, and especially these interactions with disturbances, have the potential to change what species we have, what kind of trees, what kind of shrubs, and the mixes of these we might have in the future. And there are some places where we're going to have more fire and more drought, where we might have different kinds of vegetation like shrublands in the future, because trees aren't able to compete in those locations anymore. So of course, this has implications for our carbon storage. When we have these transitions in ecosystem types from forest to non-forest, when we have our large fire events, we really have the potential to lose a lot of carbon across the landscape. I did want to point out that there's some resources that are available. We just published a synthesis on how changing wildfire is affecting changing forests in the Pacific Northwest. This is open access. I can put the links here. We also developed a very general 2-page fact sheet if you're interested in taking a look, and also a story map that has it's a more visual way to interact with this information. I do want to mention there's some information on adaptation in here. I didn't have time to go into a lot of that today, but I will say that, there's some trade-offs between forest health and carbon storage. And in some cases, the actions we take to reduce risk of fire to communities, continue to provide wildlife habitat, and keep our fire hazard down overall is not necessarily going to be a good thing for carbon in all types of forests. So there is that trade-off there, but it is very important to consider the projections for future fire when we're thinking about carbon and mitigation in particularly our fire-prone forests on the east side of the state. With that's all I have today, but feel free to get in touch with me if you have any other questions or want any other resources. Thank you.
Excellent. Yeah, thank you so much, Dr. Hollowski, for joining us and presenting today. And we have one additional presenter, an interested party. He'll be presenting in just a moment before we move into our question and answer period. We've got a lot of great questions coming through in chat. We are going to take just about 30 seconds between presenters to spend however you want to spend it, but just to give you all a little bit of breathing room between presenters. Excellent. Well, thank you so much, Jessica Randall, for joining us. Yeah, Jessica will be presenting on actions to improve forest health and resilience as an interested party presenter. And Jessica is interested in the impacts of climate change on forest health and has formed the Emergency Conservation Committee of the Pacific Northwest, a local environmental group, as a platform for environmental education and action. So hearing from her on a local perspective about actions to improve forest health and resilience. Thanks for being here, Jessica.
Thanks for inviting me. So my name is Jessica Randall. I'm an acupuncturist, and I live on 16 acres of forest land in Jefferson County. I live on land that was originally the territory of the Chimicum people. Some of what I tell you will be a reiteration of what we've already heard today, but my focus is more on what we can do to improve forest health and resilience. And I'll be giving you a copy of my research to the Climate Assembly, so it'll be available to you if you want to look up my references. Anyway, I want to thank the Washington Climate Assembly and you for being such a positive, a part of positive change. And slide 2, please. The forest makes up 52% of our state's land and is therefore a large part of our climate change agenda. And at this point, our trees are the best way we can sequester carbon, and their survival is paramount. Culturally, we've been thinking of climate change adaptation as a punishment, as a step down, but I see it as progress. I'm a healthcare practitioner, and I treat people with physical and emotional issues. Living more in tune with the environment may be something our society needs to be healthier in both body and spirit. Slide 3. The forest is not only the trees, but it's an entire ecosystem. The ecosystem is a dynamic, diverse, and interdependent network of all living and non-living things, plants, animals, fungi, soil, water, and we're a part of that as well. All of these parts depend on one another for vitality and survival. Number 4, slide. We're just now discovering that a significant part of forest health resides in the mycorrhizal network under the soil, and this fungal matrix connects the trees and other plants to one another and acts as a transportation system for water sharing and nutrient sharing. It's one way the trees can survive drought. Our forests have been evolving for 200 million years, and climate change is happening too quickly for our forests to adapt. We're beginning to experience negative side effects such as wildfire and tree die-off, and we have to accept that the forest is changing, but there are things that we can do to help it happen with less disastrous consequences. Slide, please. Climate change itself is a stressor, but the forest ecosystem has actually been in decline for the last 200 years, and we're responsible for that. In the early 1800s, when when European settlers migrated into Washington, we began over-harvesting the trees, disrupting the soil and killing off most of the elk, who, by the way, ate that brushy understory, which played a big part in forest fire management. We've improved our forest practices since then, but unfortunately, we're still doing harm. The term forest practices refers to the legal regulations for harvesting timber and forest recovery. Slide, please. Medically speaking, we could say that our forest ecosystem is now suffering from a chronic disease with a host of opportunistic infections. When there's stress on the forest, the trees become more vulnerable to dry, hot summers and warmer and wetter winters. Their immune systems are weakened, which makes them susceptible to diseases and pest infestations, and invasive species take over. The changes that we can make now are in our forest practices, and let me describe how some of these practices affect the forest ecosystem. Slide, please. Clear cutting is logging all of the trees in a large area. Clear cut lots are hot and dry in the summer, which affects species, habitat, streams, and other wetlands. When a forest is clear cut, the soil disturbances damage the mycorrhizal network. Clear cutting also increases flooding and water runoff in the winter, which carries excess silt and other debris into the streams and lakes, harming the salmon reproductive cycle and damaging roads. All clear cuts are then treated with herbicides, often applied by helicopter. This process kills off all of the vegetation. The chemicals seep into the soil with the rain, running into streams and lakes, causing other problems such as blue-green algae overgrowth and injury to amphibians and other creatures. Monoculture planting is the common practice of planting only one tree species. In Western Washington, it's the Douglas fir because it's the most lucrative. This limits species diversity, but it also attracts certain pathogens and pests which love the conifers. Those pests migrate into the forest reserves and the riparian zones. Riparian zones are nutrient-rich and species-rich areas that are specifically located near streams and wetlands, and they're ecologically vital and are especially sensitive to damage. I know riparian might be a word that you're not familiar with. The harvesting cycles of commercial timber farms are now half as long as they used to be. The trees are so weak that they need to be harvested for about every 25 to 30 years after they were planted, instead of every 50 to 60. This shorter span further weakens the forest by increasing the frequency of the other practices. Next slide, please. All right, let's look at what's going on. I'm just going to go through this quickly. So review. Ecosystem concerns, mycorrhizal disturbance, nutritionally poor soil, native species decline, invasive species take over, pollution, desiccation, that means dryness, flooding and runoff, and which then cause these specific problems for trees: slow growth, compromised immune systems, overcrowding, opportunistic infection or disease and insect infestation, and fire risk. Okay, next slide, please. So the important thing, what can we do about it? I focused earlier on 4 forest practices: clear cutting, herbicides, monocultures, and short harvest cycles. But there are more things we can do to help our trees into the next century. Some of these actions are from our own Department of Natural Resources, and others are from forestry experts and environmental studies. So I'll go through some of these, and some of these I'll skip because of time. But basically, that first one, establish an equal dialogue between nature and industry. This may seem lightweight, but it is perhaps one of the most important issues we have. The inequality between the timber industry and the environment has become an impediment to most environmental initiatives in Washington state. If you're interested in this, look up rights of nature. Stop clear cutting and implement variable density thinning. A local forestry expert named Mallory Weinheimer told me about this. It's a timber harvesting technique that preserves the forest ecosystem and grows large and healthy trees. It would be a great alternative to clear cutting. Number 3, avoid the use of herbicides. I believe there are solutions other than using chemicals like glyphosate and other cancer-causing chemicals. We have to talk about noxious weeds and the invasive species and how to deal with those. So number 4, increase the size of...
Sorry to interrupt.
1 minute?
1 minute, yeah, thanks.
Okay, thanks. Increase the size of protected zones around riparian areas. Remember those sensitive areas. Currently, they're about 25 to 50 feet, but they should really be extended to about 100 to avoid the chemical runoff and other damaging effects. So a lot of these other things, like limit logging on public lands until we are more carbon neutral, lengthen harvest cycles when possible, use local resources for milling and wood products manufacturing, support businesses which produce sustainable materials so we can give our forests a rest for a little while and regenerate, and improve restoration in general with drought resistant natives and that kind of thing. Develop products for trees that we actually have in our area. That'll keep us from having to ship things and keep our carbon footprint down. Okay, next slide. It's up to us to do this. Confronting our own role in climate change is difficult to do, but if we don't take responsibility for our actions, we will have no power to change them. There has always been a lag time between scientific findings and legislative action. Sometimes this lag time has been months or years, or as we've seen with climate change, it's been decades. We've allowed our legislation to lean toward corporations and profit, not toward the preservation of nature. Now, with global warming, we need to change our priorities. Nature should be our main concern right now, and the trees are the highest priority. And my final slide just has my name and website. Thank you.
Thank you so much, Jessica. Thanks for sharing your local perspective. And with that, we're going to move into the question and answer period. I'm getting a lot of great questions throughout the course of the morning today. And reminding folks, it's never too late to submit a question. So even though we've been bringing the questions that we've been seeing in the chat, moving them into our shared document to know what question comes next, there's always time to ask a question. And with that, I will move into the first question. This is a question for Dr. Mead. You mentioned, from Travis from Snohomish, you mentioned 37% of our emission reductions could be accomplished by restoring forests and coastal habitats. How do we do that?
Is that from, oh, this is a Q&A. Okay, because I sent some more information in the chat to folks, a really nice Nature Conservancy piece on this. So I guess the solutions that I've mostly seen have been around 3 areas, and they're described there, but it's around maintaining and restoring habitat. So reforestation, restoring our forests. It could be here in Washington, especially blue carbon. So Paul Williams was talking about that as well. Restoring our coastal marshes, our seagrass beds. So a lot of it is about restoration, reforestation, replanting habitats. There's a lot to do with also how we use land. So there's a lot of our natural solutions also lie in agriculture, and the kind of farming that we do to maximize carbon storage in our soils, and also what we're growing. And so a lot of those natural solutions also have to do with emphasis on using more plant-based diets. I don't want to get too involved here because I know there's a lot that goes into talking about what we eat and the implications of that for all kinds of justice issues. But one of the key natural solutions in there is around what we grow and what we eat and how we grow it. But if you want more information on that, I would recommend reading the piece that I put in the chat earlier, because there's a nice video in there about natural solutions. But I will say that there's been a lot of hype around, like, we just need to plant 1 billion trees and plant them everywhere. And that, I just want to be clear, that's a really an oversimplification, because a lot of places trees don't belong. So I would say more generally, it's about restoring our natural habitats, and particularly those that store a lot of carbon, like our Northwest forests and blue carbon, the carbon stored in our coastal habitats.
Great, thank you so much. The next question is from Angela from Vancouver for Dr. Hollowski. If increasing fires are inevitable, then what can be done after to mitigate destruction or speed up regrowth? Have scientists developed any solutions?
Yeah, there are a lot of approaches to reforestation. I guess what we have to be careful of in reforesting some of our forests is that if we plant too many trees there and they all grow back, and that creates a lot of fuels, and those forests may be susceptible to fires in the future. So the U.S. Forest Service in our region doesn't do that much reforestation anymore, partly because of funding, but also because we get natural regeneration in a lot of these places, and it's not as dense as the trees aren't as dense as they would be if we planted. But really where we can reduce fire hazard and risk is through what we do before a fire occurs. And there are ways to reduce fuels, especially around houses and places that we really value. And that can be through thinning our forests, making them less dense. And it can be with hazardous fuel treatments, getting a lot of those small sticks on the forest floor out, getting rid of some of the small trees. And prescribed burning can also play a role in that. It serves the same purpose of reducing our fuel levels in our dry forests. Not so much on our west side forests, but on our dry east side forests can reduce fuels and lower fire risk.
Great, thank you. Next question is from Catherine from Bainbridge Island for Paul Williams. Uncertain why we declare a state of emergency, how that benefits, or how big is the state of emergency to cover?
Well, I think that it's an action that can. It's with politicians. If they accept a principle, then they could act, and it's a declaration that we need to do something. We've known about this for a long time, and we don't seem to be really making much progress. And I think it's because that we think somebody else maybe coming down the line will fix it. And at some point, I think you have to decide that this is something we have to act on now. And by declaring it a state of emergency, that could mobilize people to act. It could get other people to think about whether it is an emergency and whether we need to take actions. I think with education, we have a very, very slow rate of change in education. It's a very enormous potential that if we could reform education, get lessons that are up to date into classrooms, people could change behaviors and also prepare for the future. And unless we declare a state of emergency, I think it would help make other changes. I'll leave it at that.
Great, thank you. The next question is for Jessica Randall from Travis in Snohomish. What besides the preservation of the environment and combating climate change is in it for logging companies to change their practices?
Well, logging and other milling and wood harvesting, it actually has gone down significantly since probably 1940 or 50. I know we have dips around the Depression and that kind of thing. And as what's happening with these large timber companies is that they're often selling off property that was forested, that was forest land, for real estate and things like that. And so they're actually becoming smaller and smaller, and they have been doing that for a long time. And so what we're seeing instead are these other companies, like they're called CLT companies. What are those? That composite laminated timber manufacturers, people who are taking some wood products, but then they're also combining them with other composite materials, some of them recycled, even from like Boeing fuselage, amazingly. Has a lot of carbon in it, has a lot of, elements that we can use for building materials. They're starting to develop those products. And I think that that's our natural way that we're going anyway. So we might as well just subsidize and assist those corporations to help, have these other sustainable materials processing plants and things like that, and that kind of research. We have to go through, process to make sure it's standard for construction and all of that. But a lot of these things are already being developed in Europe, and we can, we have like, we can even follow like Sweden's lead and Germany's lead and say, what are you doing with your forests? I know that there's a whole thing with like biochar and stuff like that, but I kind of feel like we're just going to shift, and we might as well do that more consciously and take care of our loggers that way, you know, give them something else to do. So,
And this next one is like, yeah, that's
Mhm.
helpful. Thank you. This next one is a combined question from Clifton from Wenatchee and Angela from Vancouver for Dr. Hollowski. You mentioned about forest patches that are more susceptible. If the patches can be identified, wouldn't targeted forest management be a good mitigator? And how expensive is this?
Yeah, absolutely. We can try to, and there are scientists who are looking into this now, trying to figure out where we have repeated high severity fires. Are there locations on the landscape where that happens? Are there locations on the landscape where that doesn't happen, where we might expect there to be conditions to persist with climate change? They're kind of, we call them refugia. But in the patches where there are repeated high severity fires, we could look at those and try to reduce fuel levels in those areas. And it is expensive, and it's difficult because our land management agencies don't have sufficient funding to do as much of this kind of work as we would like. There are some more initiatives with our state, Washington Department of Natural Resources. They're putting a lot of resources into that kind of work on the east side of Washington. They're working more and more with federal agencies to do that kind of thing, but the cost is prohibitive in many cases. I think you're still muted.
I was still muted. Thank you. The next question is from Garrett from Cleellum. Does any local, state, or national government provide subsidies to farms for carbon sequestration similar to growing corn or soy? And does one presenter want to take that?
I can say I'm not aware of any such subsidies.
Okay. Great, thank you. Next question is from Travis from Moses Lake for Dr. Hollowski. Can we decrease the occurrence and severity of the forest fires with increased forest management services?
I'm not sure what you mean by forest management services. I guess we could look at wood products as an ecosystem service. There are some initiatives to, the problem with the fuel reduction treatments is that they should be focused on smaller diameter stems. So these aren't necessarily our valuable timber products that we're used to. And so it's hard to get monetary value out of taking that material out of the forest. And that's a continuing problem. There are some potential solutions that people are looking into. And so biomass burning was one of those that there have been a lot of people looking into that possibility. There are more and more mills who will take small diameter stems and use them for wood products more than I think has been the case in the past, but that's still a challenge, is to make those treatments economically feasible instead of just a loss.
Excellent, thanks so much. And with that, we are going to close our Q&A portion for the first set of presenters and move into our break and/or optional networking with your fellow assembly members. And just a couple of reminders, we are going to use the same groups that we used on Tuesday night at the end of the session to move into these breakouts. You do not need to turn on your screen. You do not need to unmute yourself. This is your break to spend how you want, but we just want to provide additional opportunities to try to create the space as if we were together in a room and you were going to get a cup of coffee or grab some snacks and speaking to other assembly members during those times. But it is optional. And other reminder, just if you are sharing something, these groups they're smaller than 80, but they're still bigger than, say 10. If you've spoken, giving other folks a chance to speak as well. And speaking from your own experiences and not passing judgment on something that somebody else is sharing. So being respectful to everyone in your group. And with that, Emily, if you want to just let me know when we head into the breakout rooms, you will.
Okay. You're opening now. It looks like everybody has made their way back from what I can tell.
Great, excellent. Well, welcome back everybody from your break. And as Emily mentioned, hopefully everybody had a chance to stretch, grab snacks, grab water, blink. Sometimes I forget to blink when I'm staring at a screen for a long time. And with that, we are going to move right into our second session. And we have 4 presenters here today and a mix of expert presenters and interested parties as we did in the first round of presentations. Our first speaker for today, for this next session, is Brandon Letzinger, who will be presenting on bioregionalism, and as an expert presenter. And Brandon is the founder of the Department of Bioregion, a Washington state nonprofit seeking to shift climate action to bioregional frameworks that are equitable, representative, and sustainable. His work has been featured in Time Magazine, NPR, BBC, and more. And the learning objective here for Brandon to share with you all is about regional ecosystems and how they work and how they're connected to each other. Thank you so much for joining us.
Hi, everyone, and thank you so much for having me. Let's see, I'll just... Are you able to see my screen okay? Great.
Yes.
Well, yeah, thank you for having me. My name is Brandon Letzinger. I use he, him pronouns, and I'm speaking today from Seattle along the Salish Sea on unceded Duwamish territory. I'll be here to talk about bioregions, bioregionalism, and why developing regional strategies for fighting climate change is so important. If anyone has any questions afterwards, don't hesitate to reach out, either via social media or email. Always happy to answer questions. If you've never heard of bioregionalism before, it's one of the oldest new ideas currently out there. It has been a part of Western science for about 50 years, but practiced by indigenous peoples around the world for thousands. At its most basic, it simply means living responsibly and using place-appropriate technologies within the confines of what our region can sustain. Optimally, it means that we are not only living sustainably, but are restoring and enriching the systems on which we all rely. This can be summed up as find your place on the planet, dig in, and take responsibility from there. Rather than citizens of the United States or Canada, bioregionalism promotes the idea that people are instead citizens of their watersheds. Regardless of political difference, by sharing a place, a region, a home, we share common values and concerns that arise from this, and must find specific strategies that will work best for all of us living here. For those not familiar, a bioregion is a region defined by the natural environment rather than man-made divisions. The external boundaries of a bioregion are hard and jagged, mountain ranges, fault lines, geology, hydrology, and from these hard edges, interconnected systems of rivers, weather patterns, ecosystems, soil types that all together define the shapes of our bioregion. This includes watersheds, ecosystems, and human communities. Such an area must be large enough to maintain the integrity of the region's biological communities, our habitats and ecosystems, and to support important ecological processes, such as nutrient and waste recycling, mitigation, and stream flow. And to include the human communities involved in the management, use, and understanding of these biological resources. It must be small enough, though, for local residents to consider it home. A bioregion is unique in that it's not just defined by natural borders, but also by the people living there. It must have a unique cultural affinity. It means that the livelihoods and interests of local communities should be the starting point and criteria for regional solutions and conversations. A world of bioregions. Whether they know it or not, every person lives in a bioregion. All around the world, these bioregions are the natural countries of the planet if human political borders were removed. We live in a world of bioregions. For myself, my own home is here in the Cascadia bioregion. The Cascadia bioregion is a way to define the Pacific Northwest through the watersheds of the Columbia, Snake, and Fraser rivers. It stretches for more than 2,500 miles from Mount St. Elias in Alaska all the way down to Cape Mendocino in Northern California, where the Juan de Fuca Plate meets the San Andreas Fault and the Cascadia subduction zone begins. In the east, it stretches as far as the Yellowstone caldera, defined through the Continental Divide and Rocky Mountains, and these borders are chosen because within them we share interconnected watersheds and ecosystems, and from which cultures based on place arise. Since time immemorial, this region has been an interdependent crossroads of trade, language, and dozens of nations stretching for as far as the salmon swim. Today, the Cascadia bioregion is home to roughly 16 million people, the 9th largest economy, and some of the largest old-growth temperate rainforests, including 7 of the 10 largest carbon-storing forests and tallest trees in the world. All of this is to say that our local actions here in Cascadia can have a huge impact globally, and that we have a lot of very special things to protect. So, why does any of this matter? In terms of fighting climate change and carbon sequestration, bioregions as interconnected ecosystems and communities with shared cultural affinities become leading frameworks to help us break down large, intangible goals to a local level with specific deliverable metrics. For example, even if some worry that our timber industry might be harming the planet, by supporting locally sourced timber from Washington, we have more control over how it is cut, the supply chain, and that workers are paid living wages, and can more easily change policies we think are bad than when random hardwoods are imported from Asia. Maybe someday, introducing industrial hemp as a faster growing alternative for paper projects could help reduce the carbon output even further. Other reasons that bioregions are very important is that current borders don't necessarily represent the physical realities of where we live or our communities, that nature acts bioregionally and does not stop at human-made borders, and lastly, that these borders halt effective community action and climate solutions. Right now, it is incredibly difficult to work across borders with different laws, different languages, histories, and contexts. For effective change, these answers must be bioregional. For example, this is the Salish Sea bioregion. This is the ecoregion where I live, and it stretches from Vancouver, BC, all the way down to Olympia, Washington. It includes more than 9 million people, more than half of the entire population of the Pacific Northwest. You'll notice that running through the middle of it is an international border. This border cuts straight through the traditional territory of the Samiamu Nation, divides the hundreds of islands making up the San Juan Islands in Washington and the Gulf Islands in British Columbia, and was set where it is over dispute over an escaped pig between an American farmer on one end of Vancouver Island and a British farmer on the other. If you look closely, you can see Point Roberts, a community on a spit of land surrounded by Canada and completely cut off from the US mainland. Normally a geographic absurdity, but now with COVID and unable to get basic supplies, a public health crisis. Even though we are divided by an international border, we still share a watershed. Regardless of what country you are a part of, what we do in Seattle impacts Vancouver, and what Vancouver and Victoria do impacts us here just as much. This idea of bioregions is incredibly important because ultimately nature acts bioregionally, not according to arbitrary political boundaries. If there is a forest fire, it affects everyone living in our fire sheds, regardless of state. If there is a drought, it affects all of us in our food sheds, regardless of lines drawn on a map. If there is a flood, it affects all of us in our watersheds, regardless of political border. And if there is an earthquake, it affects all of us along the fault line, regardless of whether we live in an urban or rural area. Just like invisible borders can't stop wildfires, the impacts of climate change initiatives cannot stop at the border to be effective. Ultimately, no one city or state will ever be able to deal with these issues by themselves. One of the best examples of this is the Columbia River watershed, the largest in Cascadia and traveling nearly 1,200 miles through British Columbia, Idaho, Oregon, and Washington state. In all, it includes parts of 6 US states and 1 Canadian province. Its border is traced not by governments or treaties, but by every drop of liquid that finds a common path to the ocean. The importance of this river and how it is managed cannot be understated. Aside from being shared between dozens of First Nations, cities, and governments, the river is continuously at the heart of decades of legal disputes, often because of the way the river was divided into different jurisdictions and administrations and taken without permission by those already living there. In lieu of depleted salmon runs, water rights, fishing rights, ancestral rights, and the rights of travel across an international border, it also includes 15 million acres of farmland in both Oregon and Washington, the Hanford Nuclear Waste Site, and dozens of dams that are responsible for more than 1/3 of all hydroelectric power in the United States. Looking at one city or state within a bioregion is like looking at a pixel on a screen, and we need to see the whole picture. By using the entire watershed rather than just one piece, we can assess need within a holistic framework and work directly with the stakeholders we need to sway those most impacted by our choices and work with everyone to build new strategies to address these problems. Whether it is how we grow our food, produce our energy, protect the salmon, or fight climate change, these conversations and solutions must be bioregional. No one area, community, or state will ever be able to solve these problems by themselves.
We've got 1 minute left for you. Thanks, Brandon.
So, what does using a bioregional model look like? It means, at its most basic, work together regardless of boundary or belief. Think along watershed lines, not just city, county, state, or national. And make sure every community impacted is part of the decision-making process, and that justice, equity, and reconciliation is part of every solution. Use local resources when possible and place appropriate technologies that make sense within our bioregion, such as wind, solar, water, and foods, and products that grow naturally here that are adapted for our climate. And gather and use data based on regional models rather than state-specific models. So that's about it for me, and thank you so much for your time.
Great. Thank you so much for being here and sharing your thoughts, Brandon. And with that, we will take about 30 seconds. Got some good questions coming in for you from during the Q&A, and we'll actually hold off and answer those during the Q&A portion orally as well. And take about 30 seconds between presenters. Great. So our next presenters are Julianne Gale and Zephyr Ellis, and they will be presenting healthy soils, presenting on healthy soils, building healthy food, climate, and community. And they're co-presenting as 2 interested party presenters. So welcome to you both. Julianne and Zephyr are from the Mason County Climate Justice and giving a local perspective on this issue. Julianne is a community organizer and youth worker who's worked on climate in a variety of ways. And Zephyr is a documentary filmmaker, activist, and co-founder of the Mason County Climate Justice. With that, I'll turn it over to you both. Thanks for being here.
Greetings, all my relations. My name is Zephyr Elise. I carry with me ancestral knowledges from places far to the south of these regions and lands we are gathered here on today. But my people's knowledge of Turtle Island extends from the moments we first became the peoples of this beautiful continent. And it is in this good way that I have to pause and ask permission from the spirits and ancestors and the descendants of the peoples on these Squaxin Island lands for permission to speak and share what is in my heart in a good way as we all face the things we are facing together. I don't know any of you in this room, but I know we are all neighbors, and I am grateful for everyone who has put their mind to this.
Hello, everyone. My name's Julianne, and I just want to start by acknowledging that our world is changing. Whether or not we take any action on climate change, everything about how we live, what we eat, how we travel, where it's going to be possible to live as human beings, all of that is changing right now and more dramatically in the future, whether or not we choose to do anything about it. And so it seems to me that we might as well try to be proactive and take a stand to help shape the world we want to live in, a world that's good for all life. And I think that a big piece of what we need to pay attention to is that humans have very few basic needs. We need water, clean water, clean air, healthy food, shelter, and connection. And that's what we actually need to survive. And we get to shift to prioritizing those things. Many of us have experiences of sacrificing our comfort and giving something up because we have a bigger vision and we want something more, whether that's for our children or for our loved ones or for the world. And this is that moment that we have right now. And so I hope that you can take this opportunity as assembly members to think of yourselves as helping us make that shift and choosing to prioritize connection and joy and life and what we really need to live. And how do we do that in policy in ways that don't come at the expense of any other community or any other life? So I'm going to share my screen. And we're going to start with a little video. I'm sorry, let me share my screen with sound so you can hear the video.
Climate change is all about too much carbon in our atmosphere, right? But carbon's not our enemy. It's the building block of life. Everything alive is made of it. It's us. The problem and the solution are simply a matter of balance. It turns out we already have a technology that removes carbon from the atmosphere, and it's got 500 million years of research and development behind it. Plants, with sunlight and water, perform photosynthesis. They pull in carbon from the air and turn it into carbohydrates, sugars. Then they pump some of those sugars down through their roots to feed microorganisms who use that carbon to build soil. Voila, carbon moved. Plants pump it in and soil stores it. Nature's living technology is amazing. Unlike more carbon in the atmosphere, more carbon in the ground is good for us. It makes healthy soil, which is nutrient-rich, full of life, and holds way more water. This means more nutritious food and crops that are more resilient in the face of drought. That's good news for farmers, families, and everyone that eats.
So, good news, there actually is a solution and most of us have access to it, whether we're in rural areas growing the foods or we're in cities having small areas of land to tend to and grow healthy soil. The thing that we have to think about as humans is to support intact ecosystems, as all these amazing presenters have spoken about before us. We need to think that it's not just a force to cut down for resource, but it is a force that breathes for us, and it's a force that gives to a healthy underground of biological workers making life possible. And this healthy soil, the healthy soil carbon sponge, it's what makes this life actually possible on planet Earth. And it has so many different species and beings that are all important. And even if we don't see them, we have to support what is going on. An analogy to think about this, and if you have some bread and flour at home, you can do this yourself and kind of think about this idea. All those mycorrhizal, those fungi, all those underground biological workers are like the yeast in bread, and they're what really help hold that water when we get all that rain like we had a few weekends ago. Yeah, the top layers and some of the leaves and the upper things spread off, but that healthy soil sponge is really soaking in the water no matter how many times it's inundated. And it holds that and it keeps it from running off into the rivers. It's keeping the water available to the trees in the forest. It's doing so much work beyond just holding the ground and building things. Our suburban and urban soils, they're degraded, they're compacted, they don't have life. So water hits it and it just runs everywhere. it takes it and it goes, and this leads to all kinds of hazards, from flooding and landslides to wildfires and forest and other effects. And all this compaction and reduction of healthy soil, it is what is leading to desertification across the globe. And research, and people far smarter than I have done research to say that most of that has been how we've thought about growing our food and growing our cultures, our cities, and our empires. But the beautiful thing is soil actually knows how to regrow itself.
So what do we do to maintain or build a healthy soil carbon sponge? There's some basic principles. Number one, you want to keep the soil covered. And so here's a model of the same soil with different coverings. And what this picture shows is that the healthier coverage on the soil means less runoff into rivers. And it also means more water making it into the aquifers and into the ground, and cleaner water as well, making it into our underground water sources.
We have to keep living roots in this soil. It's not only what's growing on top, but so much more that's growing underneath the ground. And it is this entire biosphere. It's all these little microbes and fungi and things we probably don't even know about because they're smaller than I can see, creating cities and communities that help keep everything healthy and also help that carbon sequestration.
We also want to minimize disturbances for healthy soil. That means minimizing physical disturbances. So no tilling, no digging, clear cutting, mechanical mowing, because that breaks apart the soil carbon sponge in a way that it can't recover from easily. You want to minimize chemical disturbances. You can't create life by destroying it. So limiting pesticides, insecticides, and pollution sources. And you want to minimize biological disturbances, meaning you don't want any overgrazing or undergrazing.
Healthy soil and healthy life above and below ground means that there's lots of species and there's lots of folk and beings making this happen. And on one side, you can see when you're allowing a holistic management style, you're allowing the grazers and all the different plant species, you're getting cooler temperatures, you're holding more water on that land, and it is actually giving life. Whereas the compacted side on the other side, there's not a lot going on with life. It doesn't really support much.
And you can see the difference between holistic managed grazing on one side, the side with all the life, and where it's lacking. And number 5.
We have to pay attention to this whole picture. I know this seems really overwhelming trying to think about all these concepts interacting, but at this moment we get to observe where we are and try things and notice what happens if we're doing it with the desire to regenerate and to give as much life as possible. But we also get to respect all the thousands of years of knowledge that our host nations here in Washington hold and have these deep relationships and understandings already, and let them lead us in a good way to managing our resources.
So when we restore the soil carbon sponge, we get a lot of benefits, long and short-term climate benefits that also are good for communities and our health. For example, restoring the soil carbon sponge cools landscapes. Here you see an example of the same land and the difference in temperature between leaves and bare soil. It also reduces flood and drought. As you saw, holding more water and means less runoff, so less flooding, and also less drought because the water is there when plants need it during times of less rain. Reduces sea level rise by holding more water on land. Reduces wildfire risks by providing more water for plants. Provides abundant clean water and more nutrient-rich food locally for all life. Brings degraded and desertified land back to life. Reduces forced migration, because if you can grow food where you live, you don't have to move somewhere else. And humans and animals are much better at this type of agriculture than machines are. And so if we switch to human and animal-based agriculture and forest management, that means less carbon emitted, more connection to the land, and more meaningful work for more humans. So what does all this mean in terms of policy recommendations? We really trust your minds to take in all this information and get creative and think about what you think makes most sense for all of Washington State. But here's some nudges to get you started. Number 1, you can support farmers to transition to regenerative agriculture. Our example is New Mexico's Healthy Soil Act of 2019, but there are also some others in the chat earlier. You can subsidize living wage jobs to restore ecosystems and include paid training. I know lots of people who would love to do this for a living, but they can't afford either the training or there aren't the jobs to support them yet. We could have a moratorium on clear-cutting, monoculture, and pesticides. One example is bee sanctuary cities. You can incentivize local food growing, processing, and distributing. And this could happen in so many different ways. I'm just going to give you a few examples. You could legislate decreasing the hours in a standard work week so that people have more time to grow, harvest, and process their own food and medicine. What that means is, like, for example, you could start overtime at 20 hours a week instead of 40 hours a week. You could provide grants for microfarming and neighborhood processing cooperatives. You could create infrastructure for local composting and mulch. And, oh, well, let me open that back up one more time. Sorry, thought there was one more. Sometimes people ask, well, where are we going to get the money for all of these recommendations? And the thing is the government is already subsidizing mainstream agriculture. The government is already subsidizing multinational corporations. We have a regressive tax structure here in Washington. There's no reason we need to have the extreme wealth inequality that we have here. We get to move money towards the life that we want for everybody, which is a world where everybody has clean water, everybody has good food to eat, everybody is able to stay with their families and grow up where they, like, stay where they grew up. And I just think that that we have an opportunity here in this transformation of society to end all oppressions and to bring everybody together and end up with something even better than what we have now, even as we let go of these material things that we've gotten used to. You want to add anything?
I come from nations and people who have lived through many changing times in this world and many changing times in what government structure, economic system was at play. But ultimately we get to hold each other and grow strong communities, resilient communities, because all of us are here based on ancestral teachings and understandings and trines and experiments that have got us to this moment together. I thank you for your time and your attention.
Excellent. Thank you both so much for sharing your local perspective and joining us today. Appreciate it. And we'll be pausing between presenters before I present the next presentation for today.
Shall I share my screen?
That would be great.
Okay.
Excellent. Well, thank you so much. And now I have the pleasure of introducing Heather Trim, who will be presenting on zero waste and climate change as an expert presenter today. Heather is the executive director of Zero Waste Washington, and she's got more than 25 years of experience in environmental work, ranging from zero waste to toxic chemicals and habitat issues. At Zero Waste Washington, her focus has been on reducing upstream sources of waste and addressing downstream impacts, getting toxic chemicals out of products and eliminating plastic pollution, as well as building on the organization's signature producer responsibility of policy initiatives. The learning objective that she'll be touching on today and diving more deeply into is hearing about zero waste strategies and upcoming Washington state legislation. Thank you so much for being here, Heather.
Thank you so much. And hello, everyone. And Gretchen, if you can give me a 5-minute warning and a 1-minute warning, that would be awesome.
Great, I will do that.
Great.
Thanks.
So I'm Heather Trim. I'm executive director of Zero Waste Washington. We are a statewide nonprofit that is working to make trash obsolete. And we primarily do this by trying to help pass laws at the local and state level, research projects, and doing pilot projects in the community. We have 7 focus areas, which I'm not going to go into great depth here because I'm going to be talking about some of these later, but just wanted to show you the areas that we work in. And today I'm going to start with talking about our triple challenges, which are plastics, recycling, and food waste that are very connected to climate change, and then give you a flavor of legislative bills. Actually, I shouldn't say the word upcoming. It is now actually in place. Legislation has started. So let's start with the triple challenges. Zero waste is really interconnected with climate change. And this is a pie chart from EPA. Look at the red in the front of this pie chart. 37% of the greenhouse gas emissions are actually related to the provision of goods. That's products. It's the manufacture, transportation, and use of goods. This is a huge, huge piece of our climate change puzzle, and a lot of times doesn't get fully articulated when people are talking about climate change. This is a graph of the global use of plastic around the world done by sector, and it's from 1950 and to 2015. Before 1950, we really didn't have plastics, and after World War II is when we started to have them. And you can see that it has just been growing, growing, growing. And in particular, look at the blue at the bottom. That is packaging. The challenge we have is that between 30 and 40% of what plastic is being used for is single-use packaging, like bottles, bags, the wrap around your toilet paper, the wrap around your candy wrappers. These are all things that we could reduce, and they're things that we use for just a minute or two, sometimes a little bit longer, but we basically fundamentally are then going to not continue to use them. So we're not talking about things durable like your glasses. And what is plastic made of? It is made of oil and gas. And part of what has happened here in the United States is we've had a boom in fracking in the last 2 decades. I'm actually a geologist. And when I was in grad school, what I learned about was these shale beds that we had in North America that were not economic to mine from until they developed new techniques, which are called fracking. And that is why we're actually now a major exporter of oil and gas in the world now. And what this has led to is a huge increase in new plastics resin refineries. This is one near Houston, but there are all these new proposals all around the US because the petrochemical industry is saying, well, if we're not gonna be able to use our material for fuel and energy, we're gonna use it for plastic. So there's an explosion in this type of refinery being built all around the US and the world. And it is actually something that is a very big environmental justice issue. And also what has happened is we have all these different types of new materials that have come online. Every single thing on this slide is not recyclable. That can in the lower right-hand corner, that is actually not metal. That's a metal top with a plastic can melded together. They cannot be recycled. Everything else here is not recyclable because it's multi-materials put together. And then, of course, as you all know, when you approach a tri-bin like this, there's this thing called the 3-second shrug. If you can't figure out what goes in which bin, you give up and you just put it in the one closest to you, and that causes all sorts of contamination problems in our recycling stream. So that's about sort of recycling and plastics. What happened a couple of years ago is China said, no more, we're not going to take the waste of the world. And this was a very good thing for their own environment and their own circular economy, but it has caused a recycling crisis in the rest of the world, particularly here in the Pacific Northwest, because about 60% of our material was going to China. That's recyclable plastics, papers, scrap metal, etc. And so in the meantime, in regard to the recycling crisis, this is the cost per household in Washington for your recycling if you live in the unincorporated areas, the UTC, which is the Utilities Transportation Commission. It's gone up in the last 5 years dramatically, the cost, but unfortunately, the amount of recycling and the service you're getting has not gone up, and our rate of recycling has actually gone down in recent years in Washington. So why is recycling a good thing from a climate change perspective? It is way, way better from an energy savings if you can recycle things than make them from scratch and from pulling from the extraction. So the best example, of course, are cans. If you see the top there, 95%. But even glass is extremely good to recycle rather than to take from virgin materials. And you can see plastic is actually quite high up there as well. Now let's move to food and organic material. This is an excellent report, which actually your host, Cascadia, wrote. It's an awesome report, get credit to them. They do it every 5 years. Ecology does this, and they look at what is the material going to our landfills in Washington. So this is a graph showing all of the materials going to the landfills, not going to recycling or compost. And you can see that the largest component is organic material, 28.5%. This is a big problem, big challenge. This is that same information looked at a little bit differently. This is saying what are the most 15 most prevalent material types. And you can see that I've put a box around food, and they very carefully have delineated edible food and inedible food. And the punchline here is this: 17% by weight of what is going to our landfills is food waste, and about half of that is edible food. We should be eating this. We have hungry people in Washington, and the other half is inedible food. That should be going to animals. It should be going to compost. And that really ties into the previous talk that you heard about, regenerative agriculture. And why do we not want to send organic material to the landfill? And I imagine you've already heard about this, but the problem is that that landfills are a major generator of methane. Methane is 20 times more potent than CO2 as a greenhouse gas. This is a huge, huge problem. And landfills in the US are 1/3 of our methane man-made source. So now I'm going to shift to talking about legislative bills. Right now in the legislative session, there are quite a few zero waste bills that are moving forward. I'm going to only talk about the top 3 that I've bolded here because these have a very strong climate change connection, but also fluorinated gas in HVAC systems, which I'm not going to talk about, but you can ask me questions about if you'd like. So to address the plastics and recycling crisis, we feel that we need to reduce the use of unnecessary plastics in the first place, and then also build markets and restore the recycling system here in Washington instead of taking it across the ocean to other countries. So Senator Das and Rep. Liz Berry have a bill that is underway to address recycling and plastics. It includes 3 pieces. One is to require that plastic beverage bottles have recycled content in them. So instead of taking the virgin oil and gas, you would use these percentages of recycled bottles so that this would actually be incredibly powerful for helping drive the value in our recycling system as well as address climate change. Many companies have already made pledges that they are going to get to 100% recycled content. Naked in the bottom right-hand corner, they already are using 100% recycled content in their bottles. The second component is to ban styrofoam. This is a problematic item in the recycling system, major sort of contamination problem. And styrene in hot coffee, in styrofoam. If you drink hot coffee or you're eating hot soup or hot things out of styrofoam, there is a chemical called styrene in the styrofoam that migrates into the food, especially when the food is hot. And this is a probable carcinogen as of 2 years ago, they noted that. It also bans recreational coolers and packing peanuts. The next and the last piece of this bill is to ask first. So when you go to a restaurant or a takeout, you wouldn't just get a fork or a condiment pack. You would they would say, do you want a lid, a cup, or condiment or straws? So this is an ask first, and this will be a big. Are we at 5 minutes?
5 minutes, yes.
Okay, perfect. I'm actually doing ahead of schedule. This is great. Okay, so the next bill, which is my favorite bill, actually, is being championed by Mia Gregerson, who is the rep from the Tukwila Federal Way area, I believe. It's got a terrible name, so ignore the name. What it is it's right to repair. And repair is a major way to actually reduce greenhouse gases. And I'll explain that in a minute. The point of this bill is to say that the major corporations have to allow the local repair shops and the independent repairers and the public access to the parts, the tools, and the diagrams of the inside of electronic devices, everything from laptops to cell phones to Game Boys and etc. And when those devices are 5 years old, at cost, so they wouldn't be giving them necessarily for free, but right now they don't let the independent repair shops have them. So if you have, for example, an iPhone and you go in and try to get a new battery, you can't get an Apple battery from an independent shop. So this is a really big deal for small businesses and creating more jobs. So if you repair an item, you get 13 more jobs than if you recycle them. And equity. We have a major problem with COVID of lack of laptops. If we could refurbish laptops and other devices for students across the state, this is huge. And then look at this climate change impact. This is just one example. If Washingtonians use their cell phones 1 year longer, each of us, it would on average reduce greenhouse gases the equivalent of 14,600 cars in a year. This is a huge impact. If we keep our items longer before we throw them away, we have major greenhouse gas, and if we repair them. Last bill I want to talk about is Senator Doss again has a bill, and this ties in directly to the talk you just heard, to get the organic material out of the landfill and to start to use it for compost, to feed people, and to feed animals and make energy, biogas. So we have a hierarchy that we are that we use, and that's the triangle on the right here. Our first goal is prevention. Don't use it in the first place. Then reuse and repair, recycling, and then finally recovery and disposal. And as you can see, the arrow that I added for you all, the blue arrow on the left, the more you do everything at the top, the better it is for greenhouse gases. So the takeaways I have for solutions, and you might have some other really great ideas of how to address some of these things, are: 1, consume less. The less you consume in the first place, the better it is for greenhouse gases. Repair and reuse things, recycle, huge value of that, and then compost or feed people or feed animals, not landfill the organic material. And that is the end of my talk. Thank you. Maybe I'm ahead of schedule.
Excellent, you are, which is amazing. Great, thank you so much, Heather. And we've got a lot of great questions in the chat, which we'll be bringing forward during the Q&A. So thanks everybody for continuing to provide great questions throughout the course of our day today. And with that, I'm going to take a pause before we move into our final presentation for the day, which then leads to our Q&A.
Hello there.
Hi there, Jason. Excellent. So I'm going to go ahead and introduce you, Jason, before I turn it over to you. And thank you so much again, Heather, for joining us and for your presentation on zero waste strategies. And now moving into, as I mentioned, our final presentation for the day. So Jason Steinberg is joining us, and he'll be presenting on green roofs as an interested party presenter. And Jason has worked in scientific research, including at the University of Chicago's Environmental Neuroscience Lab, examining the influences of natural and urban environments on psychology, behavior, and health. Jason is currently finishing up a Master of Urban Planning degree at the University of Washington in Seattle, focusing on environmental planning and urban design with a thesis on carbon sequestration and green roofs. So Jason will be focusing on how green roofs can support climate mitigation. Thanks so much for joining us, Jason. And with that, I will turn it over to you.
Okay, thank you. I'll share my screen. Okay, hi everybody, hope you're doing well. All right. So my topic is green roofs and equitable climate mitigation. So this is what Seattle looked like before it was a city. It was lush forest. And this is it today. It's still the Emerald City after all, but it's changed a lot. But it's not just Seattle that's changed. Statewide, cities have been growing, towns have been growing. Between 2010 and 2019, Washington's population grew by 13.2%, almost 900,000 people. Meanwhile, 203 out of 218 cities grew and 58 out of 69 towns grew. So what does that mean for buildings? This is Yakima right here. It's about 93,000 people who live there. That's just an image of all the buildings. And that's Yakima on the scale of all of Washington state. So there are lots of buildings. Sorry, it's not moving forward. There we go. And so thinking about how cities are going to continue developing and growing population and in terms of their built features. How can we utilize the built environment to help mitigate climate change? And so just a reminder that CO2 gets absorbed into plants. As they grow, the plants store that carbon within them, and sometimes it goes down to the soil as well. So when we look at Bellevue or Spokane or other cities, how can we vegetate these cities in a way that is beneficial for people and also mitigates carbon emissions? So green roofs. And there are many different forms and varieties. The main ones we'll be showing here are extensive, semi-intensive, and intensive. That just means more soil, different types of vegetation. And this is the extensive green roof. This is the most common type because it's cheap and lightweight. Semi-intensive is more like a meadow and small shrubs. And intensive has trees, large bushes, and large amenity spaces. And there are a variety of types of plants that you can grow on green roofs as well. So briefly, there are a number of layers in green roofs. There's the vegetation and soil, and then the layers that protect and help the vegetation and soil, as well as the roof below. So when we think about roof space, how much is there in Washington? So it's hard to have an accurate answer, but from an analysis I did, there are about 26.7% of Seattle's land area is roof space, according to data in 2015. Spokane currently about 12.55% of the land area in the city is devoted to roofs. Now there's a wide variety of cities and forms, so let's just assume that 10% of city lands are roof space. That's about 167 square miles of roof space statewide, which is pretty much exactly 2 Seattles. So just imagine 2 full Seattles are just roofs. So let's think if we can vegetate them, what would that mean for absorbing carbon dioxide from the atmosphere? So based on a number of studies and an average of 4.5 kilograms of carbon dioxide per square meter per year means about 1.45 million metric tons of carbon dioxide absorbed per year. That's the same as all of Seattle's residential, commercial, building, energy, and medium heavy trucks. The emissions from those, and about 1.46% of Washington state emissions in 1 year. The highest number found in a study was for herbaceous perennials and grasses, kind of like a meadow. And if that was instituted statewide on 75% of green roof areas, it would be over almost 25.5 million metric tons per year. That's more than all of Washington state's residential, commercial, and energy heating emissions for 1 year, about 56% of Washington transportation emissions, about 25.6% of the state emissions in 1 year. Now we have to consider that for smaller plants, they reach a point where they don't grow anymore, but it's still going to be storing that carbon overall. But when you think about woody plants like bushes and trees, those keep growing and keep storing carbon and store more than the small plants. But that's not the only benefit of green roofs. In terms of carbon emissions, there's also reduced energy usage compared to most other types of roofs for heating and cooling. There's some debate about white roofs, and we can talk about that later. There's the reduced urban heat island effect because vegetation has a cooling effect, and that also can reduce energy use. Urban agriculture, in a way that could complement Washington's agricultural economy, could reduce transportation emissions for shipping food. A roof membrane for green roofs lasts twice as long as regular roofs, so that saves on carbon emissions for the replacement as well as cost. Stormwater runoff, saving water from being run off into the streets and sewers and air bodies, air pollution removal, sound insulation, increased biodiversity, social opportunities like communal gardens, psychological benefits, increased natural aesthetic, and more. Potential concerns that people have are about cost, structure, and maintenance. The cost is higher upfront compared to traditional roofs, but the evidence is becoming clearer and clearer that there are long-term savings from these per building, and also collective benefits, as well as job creation. And that relates to maintenance, for example. And the maintenance depends on the type. There's more in the first few years getting them settled. Structure is also consideration. There have been studies about this. There was some engineers that found in Portland that extensive roofs, green roofs, did not need more structural support. But it depends on the type, and it's a good idea to have engineers and others consider that for safety. There are a lot of policies. I spoke with people who've been involved with a lot of the policies across the nation and North America involving green roofs. Some of them are options, some of them are mandates. requiring green roofs on new construction, and there's some details to that we can get into. Recently, San Francisco in 2017, Portland in 2018, New York City in 2019, and then New York State also had a tax credit or a reduction in costs in 2019. So based on that, looking at the Washington State policies, there were some that give it as an option within a larger requirement for green space. Some give benefits like density bonuses. And then in terms of green roofs existing, most are in Seattle, a few in Bellevue, Tacoma, Kirkland, Bellingham, Spokane. Equity considerations for this less vegetated parts of the city should be able to get more funding for more intensive and biodiverse green roofs in order to help increase the amount of vegetation available and those benefits that are less available currently. This should be paired with other policies. So green roofs increase property value, and we want to make sure that doesn't lead to displacement. So we would want to increase housing supply and provide affordable housing for this case and in a larger sense. And also we want to avoid greenwashing. So green roofs have tangible benefits, but it doesn't mean that we should avoid the sources of emissions and more fundamental issues in green space, climate mitigation, and equity. So policy recommendations, I recommend a green roof mandate or requirement on all new construction and major renovations in all of Washington's municipalities. Roof space should be covered except for solar panels, heating, air conditioning, ventilation, access, amenity spaces. And the non-green portion should be white to reflect heat. Where possible, building bonuses should be used.
Jason, sorry to cut you off. We've got 1 minute.
Okay, incentivize more intensive green roofs, equitable financial assistance. Integrating this within city code could lead to faster permitting processes, gather professionals to consider the climate specific aspects in different regions of Washington, have a maintenance plan, especially in the first few years, update policy as scientific insights continue, woodier plants are better, etc. Solar and green roof combination, they have mutual benefits. Green roofs cool down the solar panels, make them more efficient. Solar panels provide shade, so that can lead to more biodiverse green roofs. Also, looking larger, look at green walls and solar walls. This is an example in Seattle right now. And then some other examples of green walls that have similar benefits. So thank you to several people I've talked to. References, I know I spoke fast. I'm happy to go into any more detail. I'm also gathering more references to share with you. But thank you so much.
Excellent. Thanks, Jason, so much for joining us and sharing your local perspective. And with that, we are going to move right into our Q&A period. Again, feel free to grab a glass of water, grab a cup of coffee. And we've got a half hour left with you all, and that involves our Q&A portion and then also the around the campfire reflection, general check-ins with your fellow assembly members. And so first question for Q&A is for Brandon, and this is from Puneet from Sammamish. Are bioregions recognized by countries/local governments?
Yeah, it's a great question. The short answer is that bioregions and ecoregions are recognized by a wide variety of governments around the world, but that there's no standard definition or ways that they're implemented. So Canada uses maritime bioregions. The United States federal government uses different levels of ecoregions, and probably Australia is the closest to incorporating bioregions in parts of their planning and in public health, as well as their environmental policies. But I think that Cascadia probably has one of the most well-defined bioregions that currently exists.
Great, thank you, Brandon. The next question is from Bethany from Morden, and this is a question to you, Heather Trim. How much carbon is produced in the recycling process?
I saw that question. I don't know the answer. What I have are the relative benefits, and I could definitely look that up and figure it out for you. Because what we're looking at is if you recycle or if you don't recycle, what is the major benefit of that? But yeah, there's no question. If you recycle, you are using greenhouse gases because you have to have the transportation to the facility, you have to process it, and then you have to make new things. So it's just the relative major benefit of doing it, but there is that's still consumption. You're still consuming.
Great, thank you. And the next question also is to you, Heather, from Angela in Vancouver. Is there a state budget designated for some of your suggestions?
Sort of. So we do have a litter tax that is paid by groceries it comes out to about 20 million every 2 years. And that is used to help with recycling and litter pickup and things like that. But what we're actually looking at, and this is something you all could really noodle on and figure out how this could work, is if we do carbon pricing and we're trying to get stuff out of the landfill, does that provide funding for expanding infrastructure, compost infrastructure, doing a way better job on recycling, et cetera, things like that. But there's not, other than that litter tax and some money from some oil hazard tax, there's really not a dedicated funding.
Great, thank you. And the next question is for you, Jason, from Sue from Medical Lake, and also Robert from Bellingham, a combined question to you. Flat roofs are a challenge in our area due to heavy snow. Is the green roof feasible cost-wise for steep roofs?
That is a great question, thank you. I do think it depends on the circumstance. Green roofs on steep roofs are definitely doable. There's even a rule in Copenhagen to require green roofs on new buildings that have a slope less than, I believe, 30%. And so it does happen. In terms of, so snow, there's some interesting energy benefits compared to other roofs regarding that. But in terms of the weight, when they design green roofs, they have to take into account the saturated or total possible weight. So if the soil becomes saturated with water, they need to consider that weight. So I would imagine that where there is heavy snowfall, the engineers need to consider that when they're designing it. What that means for the cost, I don't know the exact answer. It depends on the amount of snowfall. That's a good question. Yeah, but there are places where there's snow. Toronto, Chicago, New York City now with green roofs, and they get a decent amount of snow. So
great, thank you. The next question is for Brandon from Chris from Linwood. Have any of the communities across the area, oops, the question went away for just a second. Mike, yeah, thank you. Have any of the communities across the area, regardless of boundaries, started their own local conversations that you are aware of?
Yeah, I think so. Bioregionalism is really interesting in that it's not just around physical sciences. It's very much a cultural implementation and creating a sustainable culture for everybody living here and really looking for those place-based solutions. So almost every different initiative, around bioregional principles and thinking really starts with grassroots conversations, and it starts from these coalitions just like this, of people coming together, talking, and then also though talking deliberatively. And so that means coming together to really take action around an issue, not just around education and support. And so this is a perfect example of kind of a bioregional discussion. Another really good example would even be kind of how the naming of the Salish Sea happened. A lot of these discussions, I think the idea was first floated in 1988, and then there's been a lot of different meetings and planning and kind of coordination between different coalitions, especially in the 90s and early 2000s, until it was kind of finally recognized as a place in 2012. So these local conversations, I think, are where all change really stems from and starts. And then by getting together and coordinating, that's where the action kind of comes in and developing these effective strategies.
Great, thank you so much. The next question is from Zach in Bothell, from Bothell. And this is a question for you, Heather. What % of recycled material ends up in the landfill instead of being actually recycled? And let me clarify, what percentage of the material we place in recycle bins ends up in a landfill instead of being recycled?
Okay, so that is an awesome question. Because we're in a recycling crisis right now, it's called a residual. So you put stuff in your blue bin and you think it's going off to the recycle system and being recycled, but there's the residuals that don't actually end up being able to be recycled. And I was just on a webinar last week, and they said in California the level is as high as 30% right now. Now I don't think it's that bad here. We have some better systems in place, but there is no market for some of the materials. So you have glass. We have a glass place here in Washington that can recycle the glass. The metal's getting recycled really well, but the plastics, if it's a number 1 and number 2, those are getting recycled. There's good markets for those, but the 3 to 7s are very difficult. And there are items that you're putting in your bin that are not recyclable, and those become part of the residuals. So this is a big issue. And we have another bill that I didn't even discuss for next year, that if you want to invite me to one of your groups, I could talk to you about it. But that would make it so that everything that is given to residents in Washington is recyclable, compostable, or reusable. And otherwise you can't use that packaging.
Great, thank you so much, Heather. The next is a combined question from Jason from Seattle and Sue from Medical Lake about green roofs. This is for you, Jason. What are the disadvantages of green roofs, and are bugs an issue?
Disadvantages is one that often makes a lot of people hesitant, is that upfront cost, and can they afford to put it in? And this relates to a number of topics. I think one is we need, for this, and a lot of climate action is about long-term thinking. And so there are long-term cost savings, whether it's reduced energy, whether it is health benefits, whether it is several different things. There are long-term cost savings, and the studies are showing that. When it comes to people who can't afford it in the first place, there needs to, I think, be some type of way to help financially with that. There are a number of ways that could be discussed, but I think that is an important aspect. In terms of bugs, that's a good question. In Western Washington, I grew up in the Midwest, and compared to that, Western Washington doesn't have many bugs, so I haven't seen too many up on green roofs, but I don't know the exact situation in other parts of Washington. But in terms of bugs actually in the ground, there are some maybe small ones to help with, soil decomposition and things like that, but it's not an issue because there are protective layers that would prevent it from getting into the building, so that wouldn't be an issue. I can expand more on those questions if you want. I know there are other questions.
Great, thank you so much, Jason. The next question is for Julian and Zephyr from Barry in Bellevue. Let's see. What is the difference in yield between no-till and conventional plowing and planting farming?
So in the long run, yield is increased dramatically by healthy soil. Sometimes in very degraded soils or soils that have been really tilled for a long time, or a lot of pesticides have been applied, so there isn't as much life in the soil. There's a transition period of a few years, and that's a lot where government subsidies can help. But after you make it through that hard part, you have much greater yields at that point. And it's quite hopeful because unlike conventional agriculture, over time with conventional agriculture, you need to apply more and more pesticides. You need to apply more and more fertilizer because you're killing more and more of the microbes and the mycorrhizal fungi and the earthworms and all of that in the soil. So when you transition, it's the same with almost everything about climate change. You can have a short-term gain now, but you're selling the future of your children and your children's children and your children's children's children for that very, very short-term gain. And I think we got to shift our priorities. Do you want anything?
And not only does yield get better and stronger yields for the farmer, but you're getting more micronutrients, nutrient-dense food. So it's a win for the community. It's a win for whoever's going to be there. And, hopefully you're putting some of that back to compost, and your compost is going to be healthier, and adding compost back into the thing sequesters more carbon, brings more yield, brings more nutrients. So it's this beautiful cycle that when it amplifies is actually a good thing for everyone involved.
And also, reducing pesticides and fertilizers and things that poison humans, because that's the point of an insecticide or pesticide, is poison. You have healthier workers, and that's also good for the community.
Great, thank you so much. The next question is for Heather from Travis from Snohomish. What caused the major drop in plastics between 2005 and 2015?
The drop in global use, or the drop, I'm not sure what I was saying.
I believe you had a graph.
Mm-hmm.
Yeah.
Okay, so I had a yes, that's okay. I was going to point that out, so I'm glad you mentioned this. So on that graph that I showed, which was from the use over the entire world from 1950 to 2015, there's a recession that was in 2007 that actually shows up on that graph. And so I know that once they extend this graph out past 2020, 21 and 20, we're going to see another huge dip. And because it's amazing how embedded plastic is in all of our lives. So that recession shows up on that graph as that huge drop.
Great, Heather. And there's another question for you from Gabe from Vancouver. How do you help the companies that do recycle to make it a business forward decision to maintain it at a high level? And if recycling is not a viable business, it goes away. It's already nearing that level and that concern.
Awesome question. So that's this bill that I was mentioning. It's HB 1118, which we started this year and we're going to move forward next year way more aggressively. So that has the standards that everything has to be recyclable, compostable, or reusable, but it also has a major thing, which is producer responsibility. The producers pay for the end of life of recycling. Recycling would become free for everyone in Washington. It would be paid for by the manufacturers. And this is what we have in Europe. It's been in Europe since 1994, in Germany, and all in Europe for decades, and in Canada. And I didn't talk about it a lot in this because I had only 15 minutes, but it's a fabulous thing that if we could get this here in Washington, it would make a huge difference. It would basically completely revamp the recycling system. So it would become viable for people to do recycling in terms of the businesses. It would create all sorts of jobs. It would be great for greenhouse gases, and it would make it free for you all to recycle. And it would also incentivize less waste in the first place.
Excellent. Thanks so much, Heather. The next question is for Julianne and Zephyr from Sue from Medical Lake. Are there any regulations for farmers to let their ground rest, go fallow for a year or so? Is that voluntary?
As far as I know, there are no regulations in place, and I do think this is one place to think about whether it's regulation or support and subsidy to allow farmers space and support to do and make healthy decisions for their lands and their yields.
Thank you. The next question is for Jason from Michelle from Friday Harbor. How do green roofs keep mold from entering attic space? And this will conclude our Q&A for today.
Yeah, thank you. Well, I haven't read of reports of mold getting into buildings. The understanding that I have is there are numerous protective levels preventing from happening. I had to skim through the layers image on my presentation, but there are protective layers. There's a waterproofing membrane that makes sure water does not go through. That's the main reason that there isn't mold. It's a protective layer. There's also, like for example, a root protection barrier that prevents the plant roots from digging into the roof, and that would also help with preventing the water. The thing with water, the benefit of green roofs is that they absorb a lot of the water that would normally go on the roofs, and then they use it for the plants, and then it gets evaporated up. When it's very wet conditions, it's still, I haven't seen anything that says there's mold. I believe it's because of those protective qualities, it doesn't get inside the roof. But it is important to remember that the benefits for carbon, for financial, etc., in the long term are better when the green roofs are installed properly, when they're installed well. Because if you don't install it well and there is some type of leak in the membrane, then that's not good. So it's required to produce them well. But if they're produced well, then it shouldn't be an issue.
Excellent. Thank you. And thank you to all the presenters that came both in the morning and now the afternoon, and for sharing your responses to the great questions we've received from the Assembly members. I want to remind all the Assembly members, we have each and every one of your questions. We know that we didn't get to all of them, both in the morning session as well as now. We mail these questions out to the presenters, are getting responses to them, and we'll be putting them in that folder that we'll be sending you all a link to within the next couple of days. So all your questions will get answered as we get responses from presenters. And thank you all so much for your thoughtful questions. And with that, I am going to turn it over to Mike.
Great, thanks, Gretchen. So we're going to put up a slide here. Just recapping again what we heard today and bringing it back to some of our learning objectives today. Recognizing we heard from a variety of many great speakers and presenters spanning interested parties and experts. And we also recognize it's a lot of information to take in. So just zooming back out to the 10,000 foot level. So again, reminder, we had multiple experts and interested parties presenting about the environmental considerations of climate impacts and climate mitigation solutions. We heard from Dr. Mead Crosby, Paul Williams, Brandon Letzinger, and Dr. Jessica Hollowski about the climate impacts to a variety of ecosystem types and habitats, both in Washington state, but also considering how Washington state is interconnected with our neighbors as well. We also heard from Dr. Hollowski, Jessica Randall, Julianne and Zephyr, and Brandon about the potential of natural ecosystems and habitats and how they can be a critical component for climate mitigation solutions in this state. And finally, we heard from Heather Trim and Jason Steinberg about connecting environmental solutions across other sectors, specifically roofing and waste, and thinking about how can we be environmentally forward and sustainable in these sectors and how solutions, especially upcoming state legislation, can continue addressing the sources of greenhouse gas emissions. So I hope, again, we just wanted to bring it back out to the 10,000 foot level to just remind you about how all of these presentations are interconnected and continues building on the past two learning sessions as well. So now we're going to go back into our pre-assigned groups. Again, reminder that we'll be meeting with these same groups throughout the assembly, and this is just a time for you to share and connect about what you heard from the other presenters, how you're feeling, if there's other resources you've come across or read, additional questions. And we'll reconvene for the last few minutes to share out some next steps. So I'm going to check in with Gretchen and Emily to see if we have the breakout groups ready.
Yeah, thanks, Mike. Yeah, we're all set. So I will start. We'll open them now.
Great. So again, in terms of next steps, it's the same thing. So hopefully it's not anything new. We're going to have our next learning session next Tuesday evening from 6 to 8 p.m. And there we're going to begin learning some of the economics. What are some of the economic considerations of climate issues? We heard from Heather today about putting a price on carbon, and we actually have multiple speakers about beginning to explore some of those topics as well. Again, we thank you everyone for submitting questions via the chat today and also asking additional questions in your breakout groups. We've been compiling all of them, and any of the questions that the speakers didn't answer during our Q&A session, we will be emailing them after the session for them to provide written answers to all of the questions. And we're starting to get some of the answers back from our first learning session, so we'll have some to share with you very soon. And again, as a reminder, if someone can put it in the chat, the link to the survey, just to again get feedback about this learning session. What did you like? What would you like to see in upcoming learning sessions? Again, this is your assembly and we want to be responsive to your needs, your feedbacks, your wants. So again, please take a few minutes. It takes about 2 minutes to fill out that survey at that link that Emily put in the chat. And with that, it's 1 o'clock. Thank you all. I hope everyone has a wonderful Saturday and a great weekend, and we will see you next Tuesday.